Okay, since we've completed all of our tool offsets, setting those, now it comes to the time where we may have to develop a program. So first thing we're going to cover is how to start one, how to create one. So if you're not in where you see O list, you could be in other items. Just go to edit. You could also be in different areas, like if we were in the tool offsets. Just use your arrows, the left arrow or right arrow, because they'll both end up at the same spot, just going one direction or the other. And what we need to do is get back to where it shows O list. We're going to press O list, and then that opens up the window of all the programs that have already been stored. If I want to create a new one, and right now O001 is available, and we're going to keep the Fanuc concept of a program number. We can use letters and stuff in the program name. It's just for uploading, downloading on the G-code side, not necessarily manual guide I. It's easier to work with just the letter O and then a 4-digit number. So I'm going to press O, or hit new program first, then press O, and then I can just type in 1 because the leading zeros will be already inputted to it when I create it. So I'm going to hit create and so it shows you O0001. And then I can also edit the comment to give it now a name within the program itself. So we could do RST 1, 2, 3, and then alter, and so my program name is that. Once I've got that, then I'll go ahead and hit open. Okay. So once we've created one, we're going to actually give it what we call the housekeeping, the safe startup blocks for the tool call and starting the spindle. So again, we have the listing of different items down here, icons, and then we're going to press this button to go over one screen, and we're going to use the start menu. And first thing we're going to do is arrow over to the blank. That's your, for graphics only. It has nothing to do with the machining, but it's for your visual of the graphics for the simulation. So if I do cylinder blank, I'm going to hit select, and that's a round diameter in this case. So let's say I'm going to do a 5-inch billet size, and my length of the part, and it depends on what you're cutting, I could put that also at 5 inches. And my work origin, I'm going to leave it 0. So that means that the front end of the piece will not have any material in front of it. I'm going to hit insert to put that in the part program. And then I'm going to come back to the start menu again, and then go over to the tool call. Now this tool call has been created by Colchester Harrison. The tab was done by them, so you didn't have to type in G-code. Normally, the manual guide I, you would have to put in G-code callouts and the M-code callouts to activate the tool and the spindle and stuff like that, and to do movements, to get back and forth from the tool change position. They developed this so it's filling in the blanks. So the first thing it's asking for is my tool change position, so somewhere back out of the way. So I could put in there, 12 for X, and Z I could put in there, let's say 10. And the tool change TC approach method is how it wants to get back to that tool change location from wherever it's sitting. So I have the selection of Z then X, or X then Z, or a 2-axis move. So depending on what I want to get around, I will make a selection off of that. So let's select X then Z. So it's going to come out to the X location of 12 and then Z of 10 inches. Once it gets there, it's going to stop, which is going to shut the spindle off and everything, so you can open up the doors, and for a tool post you can change the tool. in here, I'm going to put in what tool I'm going to grab or change it to. So I'm going to put in there 101 for tool number 1. The start position here is actually showing it coming back down toward the part. What is the good safe location on the approach to the piece? So I'm going to put in a start position of let's say 5.2, and we're going to assume that the part is 5-inch diameter, and a Z start position, we're just going to Z of 1. The reason why we're doing this is because the cycle itself will get it up closer to the part. The return method, reverse on or off by these two selections, is that however it went to the tool change, in this case it was X first then Z, if I have the reverse method on back down to the part, then it's going to do Z first then X. So if we got to get around something, that's a good safe way of doing it. So I got that in there. I'll hit input to go to the next bits of information. And the first thing on there is the max spindle speed. What do you want to set it to? So if I put in there 1200 RPM, that will be the max of the spindle speed if I'm running CSS. So the spindle speed here, that the value we're going to put in, is all determined about, you know, am I working with CSS or if I'm going to do direct RPM. So if I put in there 500, in the forward direction, and if I have CSS active, then it will be 500 surface feet per minute. If I have RPM active, then it'll be 500 RPM. And then a selection of coolant on or off. The next page of information is if I want to add in an M0 or M1 in that tool change call out. Once I get it done, then I press insert, and that'll be my tool call within the part program. Again, this was created by Colchester Harrison, and it's implemented in the XS machines. Most other machines will not have something like this in it. So after we have our part program created and our billet information installed and also our tool called up, we're going to tell it what are we going to do with this tool. Now, the part I was going to set it up for is this one, and it's going to have, you got to imagine, the billet information. I got material on this I have to remove. So I got to tell it what is this tool going to do. I'm going to go into cycles, and I have to select how I want to attack it. I can do outer rough. I could do a finish if I'm ready for a finish, but you have multiple selections here. And the I just scrolled up. So the last one would be turning face rough and finish, and then up here I've got turning outer rough and finish. So that's the one I want to use, so I can rough this out and then come back and take a finish pass on it. I'm going to select that. And then the screen will come up for me to fill in the values of how it's going to be attacked. So I got a Z minus motion is the first thing I'm going to select, because I'm telling it I'm going to be cutting toward the headstock and not a Z plus where the direction is going to go toward the tailstock. I want Z minus on that. The cut depth is your single side pass, you know, so I'm going to put that at 0.1 here. And so each pass will be 100 thousandths depth cut, especially if I leave this rate of cut depth at 100%. If I change that to 50%, then the first pass will be 0.1, and the next pass will be 50 thousandths depth of cut, and they'll get smaller and smaller as it goes down toward the center. The next thing is my X-axis finish mount. What do I want to leave for finish? Being it has asterisks over here, that means you don't have to fill it in. but I want to leave material for the finished pass. So I'm going to put in there, let's say 30 thousandths for the X, and then Z, I'm going to leave, let's say about 3 thousandths on there. Reason I'm leaving so little because I only have 3-degree relief on my tool, and I don't want to bury the tool when I come into a shoulder. The other thing that it asks for is my different feed rates, which there's 4 of them in there. So the first one is my normal cutting feed. So let's put in there 12 thousandths per rev. My cut depth feed rate is if I have a re-entrant shape. So if instead of really diving the tool in fast, I'm going to slow that thing down if I had it. I don't have a re-entrant shape that I'm going to deal with on this, but they don't have the asterisk there, so I have to put a value in there. The cut rise feed rate is if it was coming back out of a re-entrant shape. The other place I've seen this take effect is when it's coming out of a radius. It will also use this feed rate. And if I don't put a value in there, it'll revert back to the cut depth feed rate. But typically coming out, I want to speed it up. So let's go to 12 on that. And then my finish feed rate on, you know, what kind of feed rate do I want for that finish pass? I'm going to put that to, let's say, 5 thousandths per revolution. The next screen has another enhancement from Fanuc Control, and that's my first speed override. So right now it's at 100%, so my first speed rate will be at 12. If I put that at 50, then my first speed will be at 6 thousandths per rev. Once it makes that first pass, then it'll revert back to the 12 thousandths per rev. I'm going to leave that at 100%. Then I have a choice between speed cut and cut rise. So the speed cut down here would be that at the end of the pass, they'll come off on a 45 degree, shoot back to the front, go into the next depth of cut, and come back down, come off at a 45 degree, shoot back to the front. The cut rise actually follows the contour. So when it's coming into an angle, it'll actually follow the contour out these, you know, how much is in the escape amount, and then come back to the front. This blends in better. So when I do the finish, I'm not hitting basically what we'll call a stair step going down the angle. So I'm going to leave it with a cut rise, and then my escape amount, this is how much it backs off, and I'm going to leave that at 50. The X and Z clearance is from the outside corner of the part. So, and when I come in from my clearance position, you know, because I set the tool change position, came down to the part, to a, you know, an area just outside the piece, and then it's going to wrap it from that up to the part, and I'm leaving this material or this amount to stay away from it so it doesn't run right into the part. How it gets there from that is also determined in here by the, in this case, Z then X. So do Z first, then X. You can change that to go X first and then Z, or 2-axis move. And it still will use that clearance position so it doesn't go right to the corner of the part. The end face, the third tab in here, is if I'm going to do a facing operation on the part. Now, if I got a lot of material to face off, I'm going to actually develop a face cycle. This, you know, when I hit available, this is okay to do minor cuts, you know, just clean up the surface. But if I got a lot of material, I'm going to do it in a different cycle. I'm going to leave it unavailable here, and then I'm going to insert all this information into the part program. And when it goes in, it'll bring up my drawing editor for me to start developing the part. So as we created the roughing passes and how it's going to attack the part, when we insert that in, it'll pull up the drawing window. So now we actually have to create the shape of the part that we're going to cut. So what I'm going to do on the start point, and this is just to give it room for the tool nose radius compensation to be activated, I'm going to start within the chamfer and off the face of the piece. So if it's a 1-inch diameter down here, and I'm going to have 150 by 45 as far as my chamfer start point is actually at 700 thousandths. Well, I'm going to start just below that. So I'm going to have X at 0.6 and Z of 0.05. And then I'll hit OK to accept. So now I have a start point showing on screen. Next thing I'm going to do is do a line move. And I'm going to go to left to Z0. And then select OK to accept it. Now I got a line showing up. Next thing I'm going to do is come down, because right now I'm sitting just there on that face. I'm going to come straight down. So down to X of 1 inch. And the reason I'm going to 1 inch, because I'm going to use an automatic chamfering icon that we have with this to blend that corner. And it only works at 45 degrees. So go down to 1 inch and say OK. So I got that there, and I'm going to do the CC, the chamfer the corner, and once that comes up, I'm going to put in there 150 thousandths. And it's still the part that I'm doing, and I'm going to select OK. Now, these go to asterisks because it doesn't have an endpoint. It's being calculated, so it doesn't know, won't show the chamfer until I give it another move. So I'll hit the line moving again, and I'm going to go from there back to Z minus 1 inch. And select OK. And so now the chamfer shows up. From there, do another line, come down to 2-inch diameter. So I'm just going to come right straight down to X of 2. OK. But before I finish these moves, I'm going to do a radius blend on the corner. And I'm going to put in there because 200 thousandths is typical, so I'm going to put in there 0.2. And OK. Again, it won't show it until it sees the next move. It's got to, it won't know what path to take until it has the two lines together. So we'll do another line and do Z in -2. So go to left, go -2. OK. So now we see the radius. Got another line move coming down to 3-inch diameter. So X 3. OK. Yeah. So I bypassed that radius. I can show you, we can put it back in later. I have to highlight back to last move, and I can do a radius blend and 0.2 in there and say OK. And you see that it's placed that radius where it's supposed to be. At the end of this move, I'm going to do another radius blend and put in there 0.2. OK, still doesn't show it until it sees the next move. Next move is going to go from here all the way back to Z minus 3, the line to left, -3. OK. So we have that line in there. We're going to do another line. And this time we're going to actually do a left down. So we'll have X is going out to 4-inch diameter. And Z is going to be a -4. I don't need the angle because I don't have that. But that's why the asterisks are there. If I only have one dimension and an angle, then I can do that. It'll calculate out the other endpoint. I'm going to hit OK. So that's showing up. And what I'm going to do is give it a little bit of a lead out at the end of that move to make sure the tool nose radius is past the finish point of that move. So I'm going to go to the left and do Z of minus 4.05. Just something a little bit longer than that. And then select OK. So now, depending on the size of material, we will do maybe a line off, you know, to take the tool off the part, and we can, you know, this depends on what your material size is. And so, right in this case, we're going to assume we have basically a 4-inch piece of stock in there. So I'm going to take X to, let's say, 4.1 to come straight off. Okay. Now I'm going to close this thing off, because the control doesn't know where it's going to start the roughing from until I close this off. So I'll press the left arrow key and then select this, and this is my billet here. It would be number 1, the figure 1, and select blank is connection, yes. Okay, so it closed off. So the roughing will start from here and work its way down to the part. Once I get that done, I can hit create. I'm going to insert in current program. So it now put that shape into the part program. So once that's inserted into the part program, that was the only thing I was going to do with this part, was just a rough and finish pass on it. I could, in just an example, that way you can incorporate this in any part program. Now I'll select the end here, which is the end of program. So you got end, and then I'm going to go over to program end. Again, this is a information that was developed by Harrison, just for their controls. And so I'm going to hit program end, select that, and basically it's wanting to know a safe end position, so we can get the tool away from the part. So let's say we're going to go X of 12 and Z of 10, and this is to get back there, what approach we're going to take. In this case, it's going to be X first, and then Z to get to X of 12, and then Z of 10. Now, incorporated in this is your M30, which is your end of program, your M5, which will stop the spindle, and M9, which would turn off your coolant. So once I get that filled in, I hit insert, and now we have the program end. Okay, now once I got all that completed, let's run the part and see how she looks. So I'm going to press the arrow key here until I can find this, the simulate. Select that. I'm going to select rewind, get the cursor back to the top of the program, and then I can hit start. This will give us the solid graphics on that. So we have that. I can, well, let's do the toolpath so you can see that also. Okay. The only difference is, you know, my green box is because my part that I created, I used 5-inch diameter instead of the 4-inch that the actual part is. So it just looks bigger than what the actual part is. So if I wanted to alter that, then I could actually go to alter, pulls up that information. I'm going to go back to, let's say, 4-inch diameter on that. Hit alter again. The information will be updated. Let's go to simulate and start. And I do want you to always go to toolpath, because the solid graphics doesn't necessarily show you a good ID visual. So anything that's on the ID, you definitely will see in here. So if I do the line graphics, if I see any red lines in this part of the drawing, then I've got a problem. And then when I'm done, I just hit graphics off. Last time we were going through the roughing and finish of a turning cycle. We were developing a part through there. We have added now a groove and a thread to this same part, and we want to put that in the part program. So where we last left off, well, in this case it was line 23, but what I'm going to do now is I have to activate my tool so we can do the threading cycle, or excuse me, grooving cycle. So I'm going to go to find my start menu and then go into the tool call. And again, this is developed by Colchester Harrison with Fanuc over in England. So this is just proprietary to this XS machine. So I'm going to select the tool call there. This is my tool change position, back away from the part. Let's go 10 and then 10. And then the TC approach is how we get back to that tool change position. We'll do X first, then Z. I mean, we have selections of how we want to do that, depending on what you have to move around. We'll call up the tool number, which is going to be 3, so T303. Tool 3, offset 3. And then X start position, that's going to be approaching back to the part. So the part is 4-inch diameter, and so we're going to leave it somewhere out there, clear of it. So let's do 4.5 and Z of 1. Now granted, all this material is gone because we've already turned that away, but I still like to come back to a clearance position. Then from there, we'll approach the groove in the cycle itself. Reverse method on, input, and then we're going to slow down the spindle. So max spindle speed, let's put that at 1200. And then my spindle speed, because I'm running CSS, I'm going to put in, let's say, 400 surface feet. Being it's a grooving tool, it's a softer insert, we can't really run it much faster than that. I'm going to have it in the forward direction. CSS is active and coolant off at this time. And then I press insert to put that into the part program. So after we get the tool active, we're actually going to tell it what are we going to do with this tool. So we're going to go into the cycle. We're going to select T grooving, and we have multiple selections in here. We got 1 through 9. So that's, roughing, outer interface, rough, outer finish. Yeah, so there's quite a selection in there. But I'm going to select outer rough and finish because I'm going to rough it and then finish it before I put the thread on. So I'm going to select that one. And I'm going to start filling in the information. We got center cut, the first thing, or layer. Center will actually come to the center of the groove, and if I got a pecking cycle active, it will peck down at the center, come back out, step over, and start opening up and widen the groove up. Layer will actually go into the first peck depth each time along the same diameter, so it'll open up the groove at the first peck depth. That's good for getting coolant down there if it's a deep groove. But in this case, I'm going to use center cut, and I'm going to do how much on the side finish? Let's say 2/1000. Bottom finish, I'm going to leave that at about 2/1000. We don't need very much material in there for finish because you'll have deflection anyway. So when you go to do the finish, you'll have actually more than 2/1000 in there. My rough feed rate, I'm going to put that around, well, let's say 5/1000 per rev. My finish feed rate, let's do 3 to give it a fairly decent finish. The next thing is on the pecking or nothing. So nothing just means it's gonna feed all the way down to the bottom of the groove, come back out, step over, feed down to, while it's widening it. Pecking will actually break the chip as it's going down in instead of winding up a big curl of chips. So I'm going to keep it on pecking. And then my pecking cut depth, we'll put that at, let's say, 50 thousandths. And the rate of cut depth, this is a nice little feature that Fanuc has put in there, but right now it's at 100%, so each peck depth will be 50 thousandths. If I change that to 80, then the first peck depth will be 50, the next will be 20% less, and so on. So it just takes the pressure off the part as it's going deeper. The return amount is, we've got it set for 5 thousandths. That's plenty. It'll back it up to break the chip. The next part of it, of this roughing information, is our clearance. When we approach the part, it'll remain away by 50 thousandths. And then how much dwell we have at the bottom, once we get down there, I'm going to leave that at 0. And then the approach from, when I came back from tool change, I stopped out here. So it's going to do a Z first, then X to get to the start point of the groove. So we'll leave that there. We have different selections that we can choose from. My end cut position is for the finishing. So we have center or corner. On the center, because I'm going to have a radius back in that corner, I'm going to use that, because that way it'll slide down one of that angle and then slide over towards center, come back out, come over to the left side of the groove, come down and slide back to center. This is during the finish pass. We'll keep those, and then we'll hit insert, and then what it will do is call up your figure of the groove itself. So like I said before, all cycles will have figures, and this one will have its own too. So like I said, once you develop the cycle itself and insert that in the part program, it comes back to what is the groove going to look like, so in this case, we're going to select the trapezoidal, because that's basically what we have on this one. So outer trapezoidal, and then select that. Now we have a question of, do we have a Z minus or a Z plus as far as your base point? So you basically go by what do you know, and what we do know is Z endpoint for the groove is going to be -1 inch. So we'll start with that as far as the Z minus. And then when we add in the other numbers, it'll work from there forward. And that's why the X and Z are highlighted back here. So the X base point for that is going to be 1 inch. And then the Z base point is be a -1. Then it wants to know the depth. Well, the bottom of the groove is at 800 thousandths, and so that'd be 100 thousandths per side from the 1 inch. So we'll do 0.1. And then D is the full width. I don't know how well you can see it on the camera, but it's got an arrow covering from the top to top, okay, not the bottom. So I'm going to give the width of 250. We'll come back to the 150 and then the angle later. So in this screen, so once I hit input, it flipped over to the next tab, which is going to be, do we have any corner breaks? There's nothing on the print, but I'm going to put one, just for an example, on number 3, which is the back one here. So I'm going to put in there, there's an arc, and the reason I'm typically doing that, because that's your shear point. If that's a sharp corner, that's where the part's going to break. So I'm going to put an arc in there, let's say of 20 thousandths. Now my tool width is 93, so I've got plenty of room in here. So I got 150 and I got 20 thousandths radius in there, so I can still do that bottom with the 93 thousandths tool width. That was done in tool calibration. Okay, so we got that. We'll hit input to go to the next thing. And next thing is, do I want to base this off of width, information, or angle? I'm going to select angle. Either one will do it, but it gives you choices. So in this case, the bottom size angle is this one here. Again, it may be hard to see the arrows, but it's showing an angle call out. And I'm going to, basically this is a 45-degree angle because the two legs are 100,000ths. The bottom size angle, or the back side, is going to be 90 because it's a square 90 degrees. If I have repetition of the grooves, we could fill in information here that I've got the same groove equally spaced down the shaft. Once I get that done, I'll insert that into the part program. Now I'm going to actually put an M30 in here to stop the program so I can do simulation without any errors. So to simulate it, I'm going to go to simulation, and then let's go to toolpath, and I'm going to hit start. And let's rewind it to the top of the program and go again. So you can see the groove being developed down in there. And let's go to animate and show you that one also. And that's the grooving cycle. Okay, now we're going to add a thread to it, to the part program. So I am going to take that M30 back out of the program. And then we're going to go into the tool call for the threading tool. So we're going to find our start menu, go again back over to the tool call, activate the tool call and start information. Go to tool change, so let's do 10 and 10 again. And again, the approach to the tool change position, X first, then Z. And then what tool number? 4 is our threading tool. The X start position is the approach back to the part, and even though everything is gone here, I'm still going to base it off of 4.5 on X and Z of 1. Down the road, you'll find that this is actually a safer thing by still staying away from the part. May not be in this video, but on your parts that you run, you'll find it's better to kind of stay at a clearance. So reverse method, on or off, we'll leave it on. And then my spindle speed is our max spindle speed. We can still put in there 1,000. We may not run it that much or that fast, but because we're going to change CSS to RPM when we get down there. So spindle speed, we have to base it off of RPM. So 1 inch diameter, we could probably run that, let's say 800 RPM. And then forward direction, but we're going to turn the CSS off and go to RPM on that. We'll leave the coolant off for this, and then we're going to insert that in the part program. And that's our tool call. Again, once we have the tool called up, we're going to tell the control what we're going to do with that tool. So we'll go to cycles, and then across the tabs on the top, we're going to go over to threading. We have threading outer and threading inner. So I'm going to select the threading outer. Either input will do it, or the select button will also pull it up. So what we have is quite a bit of selections through here. So the single amount, which is your single A, is basically talking about that's coming down one flank, one side of the thread, the same amount based off the kind of like the chip load, that not depth of each pass. So this will probably give you the better finish, the single A. Or you have both A, so it's going right down the center of the thread, and then Again, the chip load will be the same. So each pass will be less and less and less. The staggered A will bounce back and forth. Single D is, again, one side, one flank side, but the depth of the thread, each pass will be the same. That can put quite a load on the tool. So again, we'll stick with single mount A. We'll go to the next one, item. So finish amount. Yeah, let's give it like 2/1000ths for the finish. And like always, you know, if we have an asterisk there, we don't have to fill anything, but we can. We can leave it blank if we want. Number of finishing passes. Let's put in there 2. So once it takes the finish pass, it'll take 2 more air cuts or spring passes at that same finish diameter. Cut depth or number. We have a selection of which one do we want to use. So a number, if I put it in there, it's actually going to, if I tell it 10, it will rough out the thread in 10 passes, then do its finish. You don't necessarily have a control of the depth when you do that. You'll have to calculate it out by, okay, I got to go this deep by 10 passes. What's that going to come out to? I'd rather use depth. That way I can tell it basically my first cut. So I'm going to put in there like 12/1000ths depth on the first pass, and then I'll break it down from there. So approach motion, again, I'm out here somewhere, and then I'll go Z first and then X to the start of the thread, which I have not developed yet. So surface clearance on the X, if you can see that, we're going to leave it at 60/1000ths. Entrance clearance, if we have enough room, what we need to do is make that clearance basically at least 1 pitch length in front of the part, or before it engages into the part. So in this case, for 12 threads per inch, we're pushing almost 3 thread pitches before she engages. So I'm gonna shorten that up to, you know, let's say 0.15. That should be sufficient. And then exit clearance is at the end of the thread. We want to keep that at 0. You don't want a value in there, because if people end at like minus, let's say 0.99, whatever you have in here will travel even further. So let's kind of leave that at 0. We got a thread relief in there, so we can just stop just prior to the -1 inch. So once we get that done, then we can insert that into the part program. And again, a figure will come up that we have to fill in the blanks. Okay, like I said, the thread figure will then pop up after you get the roughing information in there. You know, of what the shape of the thread is going to be and what type of thread. So we have a selection in here. We got thread general, which is any thread that you create out of your mind, or just any type of thread that is given to you. The thread metric, typically you're going to use this when you're in metric. And then thread unified, you got your pipe thread, tapered pipe, and you also have your straight pipe thread. There is a difference between the two. So we're going to do general, because that'll cover pretty much all aspects of the thread. So I'm going to go into general, select that, and then I'm going to tell it it's going to be a male screw, because I'm on the outer. The start point on X and Z, in this case, I'm going to state X is going to be 1 inch, and Z I'm going to start at, we might as well pick 0, because we already have in the previous information of 150,000 standoff. So we're going to be clear by 150. And if you remember correctly, when we touched off the tool, we touched off the left side of the insert. So we're not going to hit the piece if we tell it 0. The lead of the thread, in this case, it'll be 12 threads per inch. So that's going to be 0.0833. How I came up with that is just too many years of training. But if you take 1 divided by 12, it'll come up to 0.0833. Thread depth. Well, we got a handy little calculator that will create it, give us what the thread depth is going to be for that. So I hit that, and it comes up to 54 thousandths. Now, granted, we may have to modify that if the nut doesn't go on, or if the wires aren't measuring out correctly. We can still modify that one and rerun that thread cycle. The end point of X, because it is just a straight thread, I'm going to put that in there at 1, and Z is going to be just shy of that. So let's go minus 0.95. Okay. The next 2 bits of information is for a multi-start thread. So if you got a 4-start thread, 2-start thread, you'll use this. And once we get that done, we'll insert that in the part program. Now to see this, I'm going to again put M30 at the end. And we're going to go to simulation. Rewind back to the top. And let's actually go to toolpath and run that. And so what you'll see is the purple lines in there. It may be very hard to see. So let's do this. I'm going to enlarge it and then run it again. Yeah, I should have moved the drawing over a little bit, but you can see the purple lines in there. That's your thread passes. And again, we're just wanting to make sure we don't have anything up in this area. So let's do zoom again. Go to auto, get us back to where we're supposed to be. Go to the animate. Let's get that back out of here. Smaller. There we go. And, oops, sorry, stay there and go. And there is the complete part.